ELE 245. Introduction to Microelectronics. Chapter 1, Physics and Properties of Semiconductor. Subchapter 5, Transport of Carriers. Carrier transport phenomena. The net flow of electron and hole in semiconductor will generate current. The process where electron and hole moves is called transport. Two basic carrier transport mechanisms are drift and diffusion. Carrier drift. When an electric field applied to semiconductor, electrons and holes will experience a net acceleration and a net movement. Net movement due to an electric field is called drift. The net drift or charge give rise to drift current. The drift current density formula consists of electron charge, electron mobility, electron concentration, hole mobility, hole concentration, and finally electric field. Mobility is the ratio of the drift velocity of the carrier to the electric field. Electron and hole mobilities are important semiconductor parameters. There are two collision and scattering mechanisms affect mobility: phonon lattice scattering and in-nosed impurity scattering. Formula of mobility. First the formula of phonon lattice scattering. Then the formula of in-nosed impurity scattering. And finally formula of total mobility that consists of phonon lattice scattering and in-nosed impurity scattering added. Conductivity. Conductivity is ability to conduct electric. Conductivity electric in semiconductor is not too good or too bad. The ability of semiconductors to conduct electricity can be greatly improved by replacing or adding certain donor or acceptor atoms to its crystalline structure. The derivation below show that the conductivity formula can be derived to get the Ohm law. Carrier diffusion is the process where particle, electron and hole, flow from a region of high concentration to low concentration region. Diffusion current density. There are two mechanisms of diffusion current density. That is, diffusion current density of electron and diffusion current density of hole. Diffusion current density of electron. Flux of electron flowing in a negative x direction. Since electrons have a negatively charged particles, the conventional current direction is in the positive direction. If the density gradient become the negative, the electron diffusion current density will be in the negative x direction. Diffusion current density of hole. Flux of holes moves in the negative x direction. Since the hole are positively charged particles, the conventional diffusion current density is also in the negative direction. Total current density. There are four possible independent current mechanisms in a semiconductor. That is, the electron drift, the hole drift, the electron diffusion, and finally the hole diffusion. The total current density consists of this four mechanism combined.
Created using PowToon.